the unit circle. Again, we're going to go back and use our special right triangles, the 30, 60, 90 and the 45, 45, 90, and we're also going to use our trig ratios. Remember, in a 30, 60, 90 triangle with a hypotenuse of 1, the side opposite 30 is half the hypotenuse, and the side opposite 60 is half the hypotenuse root 3, or square root of 3 over 2. In my 45, 45, 90 triangle with a hypotenuse of 1, side opposite 45, 1 over root 2, which can be rationalized to root 2 over 2 for both legs of the triangle. So I'm going to start by finding the sine of 30 degrees using a unit circle. Again, I'm going to use both of those triangles to the right along with the trig ratios we learned. So I create a circle with a radius of 1 unit, and I drop in my x and y axes, and I'm trying to find the sine of 30 degrees. So from the positive x-axis I go up about 30 degrees, draw a radial line with a length of 1, drop a perpendicular, and I make a 30, 60, 90 triangle out of it. Again, using my special ratios, opposite 30 is 1/2. So the sine of 30 is the opposite side over the hypotenuse. That would be 1/2 over 1, which is again 1/2. In my next example, I'll have the cosine of 210 degrees. Again, I'm going to measure out 210 degrees from the positive x-axis. This I'll do in red. Draw out my radius of 1 unit. Again, I drop a perpendicular always to the x-axis. That means that I have an angle of 30, 60, 90 again in my triangle. Opposite 30 is 1/2, but it's negative in the third quadrant. Opposite 60 is square root of 3 over 2, and it's also negative in the third quadrant. So the cosine of 210 is the adjacent side, negative square root of 3 over 2, over the hypotenuse, 1. So the cosine of 210 is negative root 3 over 2. In my next example, again, I set up my xy axes, draw my unit circle. This time, I'm looking for the tangent of 315 degrees. I locate 315 degrees from the positive x-axis, draw my radius of 1 unit. Again, I'll drop a perpendicular to the x-axis. The angle between the radial line and the x-axis is 45 degrees, so I have a 45, 45, 90 triangle. Each leg, square root of 2 over 2. The vertical leg of the triangle, though, is a negative root 2 over 2 because it's in the fourth quadrant. Tangent of 315 is the opposite side over the adjacent, or negative square root of 2 over 2 over positive root 2 over 2, which is negative 1. In my final example, I'll look for the sine of 5 pi over 6. Since that's given in radians, I can convert it to degrees, so it would be equivalent to the sine of 150 degrees. In green, I'll measure out 150 degrees from the positive x-axis. Again, draw a radial line. Hypotenuse is 1. I drop a perpendicular, and I'm creating a 30, 60, 90 triangle. Opposite 30 is 1/2. Opposite 60 is square root of 3 over 2, but it's negative because it's drawn in the second quadrant. So the sine is the ratio of the opposite side, positive 1/2 over 1, or 1/2. Remember, in the xy plane, in the first quadrant, all the trig functions are positive. In the second quadrant, sine and cosecant are positive, Third quadrant, tangent and cotangent and positive. Fourth quadrant, cosine and secant are positive.